Hey guys, welcome to another module of the computer forensics class where we're going to talk about Unix daemons, processes, and how to examine log files. I'm DSP, and the outline of this module is we're going to talk about certain services, special processes that serve requests from users or other programs, and these processes, if they are hacked, it has security implications because they are, as I said, again, privileged. This process also log data in certain parts of the system, and we're going to learn where they are and how to examine them. We're going to get a rough idea of how processes interact with each other through sockets, files, other inter-process communication mechanisms, and we're also going to examine the memory of a running process via debugger or by offline memory analysis. And we'll also talk a bit about how to extract memory from a live system. So daemons, as I said in the beginning, are privileged, usually long-running process on a system that serve requests. When you connect to a web server to get a web page, there is a daemon probably serving this request on the web port. That used to be port 80, now it can be mostly port 443. But anyway, it receives a request, it finds the appropriate page that needs to respond back to you, and it gives it back to the client via the HTTP protocol. Now, because usually this process need to perform privileged actions or access privileged parts of the system, they are usually run with as root or as an administrator in Windows, and they also usually run continuously because they need to be there present when the request comes in to be able to serve it. They are usually started from the init process in Unix, which is a process that has a process ID of 1 traditionally, and this init process then spawns the rest of the processes that make up the running system. As we said, because they need to access certain special parts of the file system, or even bind to a port below that has a port number below 1024, that makes them it requires them to run as the root user. They also may hold certain secrets, like for example your OAuth tokens or Kerberos tokens or other JWT tokens that we talk here in the case of web-like service. They keep logs in certain parts of the system, or they talk with the logger of the system, and they produce logs that the logger then writes into the appropriate place. And here we have an example, and you can click on that video and you can see, for example, the FTPD, which is the file transfer protocol daemon. FTPD listens to port 21, and that's why it needs to execute as root, and just serves back files, so you can connect on an FTPD port, and then you can, for example, request to see which are the files that it knows about in the directories. Then you can navigate in these directories, and you can get a new file from there. So you will download a file or put a file where you upload a file if that is allowed. So yeah, check this video to see how FTPD kind of works. Now, even when everything is okay on daemon and it runs as intended, it can be misconfigured potentially. Like in the previous example that I mentioned, if you can upload a file on an FTPD server, well, if the configuration there is wrong, you might be able to upload a new configuration file for the FTP server, therefore further elevating your privileges. There could be logic errors in how this setup is done, or how the daemon is written, that could also lead to certain security bypasses. There could be insecure defaults. We all know, routers that are around that can probably still log in with a username admin, password admin, and so on. So when there are memory corruptions, like buffer overflow. So that means, things are not, the code has bugs that can be exploited. Then if an attacker successfully executes such a memory corruption attack on the system, they can potentially inject new code to the process, which is now going to be running with higher privileges. And if the process was running as root before, then the shellcode that was injected by the attacker will also run as root, thus leading to a complete system compromise. In case of logging, we said that these processes, the daemons that are running, they are producing, hopefully they log the events that they see. There are different places where system logs usually go, but this is just convention. We're going to talk about the main convention here. We have /var/log as the main directory that usually holds logs, and there is var log secure, for example. When you do sudo something and you type the wrong password, then that event is logged into that var log secure place. Okay, it's just a text file that says this user tried to run sudo, for example, and it was a failed attempt. They provided the wrong password. Now you can imagine that if you have some smart, local user that is trying to brute force your sudo password by just running, John continuously and trying to find a new, the admin sudo password with using a word list or just their own program, then varlog secure is going to start holding too many of these events, and by examining that you can see which user is trying to brute force your system. Then we have varlog daemon, and usually all the network facing daemons are logging there. We have WTMP, which says which user is logged in currently at the system and when they did log in or log out, and authentication log, auth.log, so which user logged in at any given time. Now these are just files, but if you remember from the first modules, you can use tail-f, which does a continuous polling of the file and displays any new lines that might be appended on the file. And if you do tail-f any of these log files, you're going to have a pretty nice, live view of the events as they're happening. Then a nice thing with plain text logs is that then with the things we've learned already, you can, for example, sort them by user ID and then only isolate one user ID from there, or grep for user ID, or sort them by time, for example, if you need to, or use awk to just cut certain fields out of the output. But not now these days on a desktop Linux system, because systemd has been systemd is started as a replacement of the init system that I described before, where it's not just a simple init process that starts spawning. You use a simple configuration, as was the previous sysv init, to choose which process start. Systemd is a more complicated system that can spawn processes concurrently, and then it can wait to see if process spawn correctly to spawn another process, and it has a more complex setup. It also this systemd program took over logging of the system. So now processes that want to log through systemd have their logs stored in a binary format. So if you had to examine them directly, the log files, with using, for example, grep and awk, you wouldn't be able to, because they're now stored in a binary format. Therefore, you need to use this journal.ctl program to turn the binary logs back into text and then operate on them. Also, the place that I told you before that in most Unix systems was /var/log, that kind of changed now. and with systemd, and you might find logs in /run/log. You can see this video that I'm linking here, which uses again the FTP daemon, and we see how the FTP daemon logs events as they're happening. Now, you should understand by now that log files are fantastic, but if an attacker actually manages to gain access to a system, then the logs can be tampered with. Of course, the attacker can delete the logs, or can delete only the parts of the logs that show them attacking the system, or even worse, plant just false clues in the log files. So please think of some solutions to this problem. What can we do? There are multiple ways to approach this problem, and let us know on Discord. Just this time, like there might be some obvious things, like someone might say, okay, back up your logs quite often. That could be a solution to that.